So hello guys, today we are going to solve a LeetCode question that goes by the name squares of a sorted array. Squares of a sorted array. The question number is 977. It's an easy question. Okay. It's an easy question, but yet it has some approaches that will help us to just grab the concepts quickly and we'll just understand how these type of questions are to be done. We'll understand the concept of two pointers. Okay. So let's move on to it. Let's move on to the question. First we'll try to read the question. Okay, so it is given that given an integer array nums sorted in non-decreasing order, return an array of squares of each number sorted in non-decreasing order. Okay, so you are given an integer array nums that is sorted in non-decreasing order. What does it mean by non-decreasing order? Basically the order that is not decreasing, that means the increasing order. Okay, so this is the increasing order. Okay, so you are given something like this, you're given something like this. Okay, and you have to return an array of squares of each number sorted in non-decreasing order. Okay, so you have to return, what you have to return? Basically this you have to return. Okay, so bhaiya, we can just at each step I can just make it like if it is the nums of I, basically if it is nums of I can make nums of I is equal to nums of I into nums of I. Okay, so this can be my answer for each number. But no, you are not right. Okay, because the array can also consist of negative numbers. And let me tell you what is the scene with negative numbers. Okay, suppose basically as you are given a sorted array. Okay, so the array can be like this, array can be like this. Okay, array can be like this. So if you try to do the same thing, if you try to do the same thing with this, okay, you will just square it and store it in this position only. You will square the number and store it in the current position only. So if you try, if I make the same array, okay, basically I'm doing it in place, I'm just showing this to for you to understand. Okay, so I'll just square this and store this. Okay, I'll square this and store this. I can square this and store this. I can square this and store this. I can square this and store this. Okay, so this is what I get. This is what I get. Okay, this is the array that I get. This is the array that I get. So is it sorted? Is it sorted? Is it in the non-decreasing order? No, no. Okay, it is not in the non-decreasing order because as you can see, any negative number also like raised to the power 2 gives me a positive number, gives me a positive number. Okay, so suppose if 0 is there and 2 is there and here -3. Okay, so this -3 is less than 2, but its square is gonna be greater than 2. Okay, so 4 and 9 is the squares that I'll get. So 9 is greater than 4. Okay, so this you have to keep in mind. This you have to keep in mind. Okay, because basically if I take this test case again, now I'll tell you the brute force solution also of this question. Okay, how I got to know about the brute force solution instantly just after seeing the question. Okay, so like if they are saying like you have to return just the squares, what I'll do is I just square them. Okay, this we have discussed. Now it has to be sorted, so I'll just sort it. Okay, so what it will be if I sort it? 0 1 2, basically not 2 4. Okay, so this is to be squared, so 1 4 4 and then 9. Okay, then 9, this is the extra cell. Okay, so this is my answer, and exactly this is what you have to return. So basically just square each of the numbers and then sort it. Okay, so you will reach upon to the solution eventually. This is my solution array to be returned. It is as simple as it looks. Okay, just square. First step is to square each number and then sort the whole array. So you will get an array that is your answer. Okay, now you will get an array that is your answer. I'll try one more test case and tell you. Okay, -7 -3 2 3 11, -7 -3 2 3 11. Okay, so I'll just square all of these. I'll just square it one by one. So 49 9 4 9 and then 121. Okay, so now I have got an array that contains the squares. Now I'll sort it. Okay, So what I'll get it 4, 9, 9, 49, and then 121. So this is my answer to be returned. Answer to be returned. Yeah, it was that easy. It was that easy. So, what is gonna be my time complexity for this solution? Time complexity for this solution. Basically, my time complexity is gonna be as you are traversing the array. As you are traversing the array once, the time complexity is gonna be O of n, O of n. But now you are sorting it, sorting it. Okay, and sorting in worst case takes O of n log n. So n log n plus n. Okay. So basically, ignoring this n, if we just ignore this n, the time complexity is O of n log n. Okay, what is the space complexity? If you want to do it in place, if I do it in place, so space complexity would be O of 1. So space complexity is optimized. Okay, but my time complexity, can I optimize this? Can I optimize this? Is it the only solution that I can go upon? No, obviously no, right? Obviously no. There must be any better solution, right? Okay, there must be any, to every problem there is a better solution. It has been discovered or it will be discovered. Okay, just listen to it again if you want to know what I said. Okay, so coming back to the question, so I have solved it using my, I have solved it. If I just try to code this approach, basically auto and IT, basically I'll get reference to it, and what I'll do is I'll just square each of the numbers and then I'll sort it. Nums.end, and then I'll return. What I'll return? I'll return the same array. Just try to run it. Accepted, and I'll try to submit. Okay, submitted. But what is the problem with this question? With this solution? Time complexity is n log n. Okay, can I optimize this? Basically, there is a follow-up that squaring each element and sorting the new array is very trivial. That anyone can do, okay, because this is a two-liner, like, right, two-liner, only two-liner. Can I optimize this? Can I optimize the time complexity? This two-liner is just taking up so much time to execute. So can I optimize this? Can I find an O of n solution using the different approach? Using a different approach. Okay. So let's see. Basically, if I take this test case, -4, -1, 0, 3, 10. -4, -1, 0, 3, 10. Okay. As you can see, these are in sorted order. Okay. So if I try to visualize like on a number line, if I try to visualize, basically if this is 10, okay, and -1, -2, and such like this, -3, -4, okay, and -10 basically. Okay. So so if I take this number line, what numbers from -10 to from -10 to 10, okay, -10 to 10 is my number line, okay, for now, for this case. So what numbers can give me the maximum squared value? What numbers can give me the maximum squared value? So if I take the extremes, like -10 and 10, both of these will give me a squared value that is like 100. Okay, and that is the maximum that I can get. Because -4, -9, -8, -7 are all gonna be squared and give me a value that is less than 100. Agree. Basically, 10 square is less than 9, is greater than 9 square, and is greater than 8 square, greater than 7 square, right? Basically, 10 square is greater than 9 square, greater than 8 square, and so on. Okay. So my extremes are gonna give me the maximum value. Okay. My extremes are gonna give me the maximum value. So this would give me the maximum value, and this would give me the maximum value. So if I just move one position, +9 and -9, so these values will be obviously less than the square of these values. These values must be less than the square of these values. Okay. So just remember this test case. Okay. So if I take this test case, -1, -4, -1, 0, 3 and 10. Okay. If I just take this test case, okay, and I make a new array, in which I'll store my answers. Okay, in which I'll store my answer. what I just told you, what numbers can give me the maximum squared value, the maximum squared value, which numbers can give me, okay, which numbers can give me. Basically, if I just see, so this number and this number can give me the maximum squared value, right? Just ignore the sign, because square is gonna give me and a value, because square is gonna give me a value that is gonna be positive for sure. Okay, because minus 8 raised to power 2 is only 64, and 8 raised to power 2 is also 64. Okay, so just ignore the signs. Basically, if I ignore the signs, okay, if I ignore the signs, so this contains minus 4 and this contains 10. Okay, so the extremes are gonna give me the maximum value. Extremes are gonna give me the maximum value, and let this array be sorted. I have to maintain a sorted order in this array. Elements, I'll store the elements. In this array from the end, in the end, such that the sorted order is maintained, such that the squared sorted array is maintained. Basically, if I keep my pointer here, if one pointer here and one pointer here, because these only can give me the value for this index. This only can give me the value, because my answer should be sorted, right? My answer should be a sorted value, right? Sorted array, right? My answer should be sorted array, right? So for this value to be maximum, what can give me the maximum values? What indexes? This index or this index? Okay, I'll just compare these values. Compare the square or these values. I'll compare the squares. So, and this square would be 100 and this square would be 16. Okay, so what is my maximum value among these? 100, obviously. So I'll store 100 here. One pointer would be pointing here. I'll just decrement it. Now I want this position to be filled. As this position is already filled, I'll just try to decrement the, I have used this, so I'll just decrement the end pointer. Okay, my start pointer would not increase. Why? Because this value can still be greater than the other values. See, if you are on number line, -5, -4, -3, -2, -1, 0, 1, 2, 3. Okay, -4 and -5. So if these are the extremes, okay, and I am coming onto the left from one side, if I'm coming from the right to the left, okay, so this number square can be less than this value, these values, because it is basically like this curve. This curve is forming, okay, basically like this. Okay, this curve is forming, be it be a graph, okay, and this curve is trying to fall. Okay, so all the endpoints will be maximum, and I compare these points. So if 5 is here and plus 5 is here, okay, so these contain the maximum squared values. Okay, I'll just, so coming back to the test case, if I try to compare this and this, basically square of this and this, so 16 and then 9, what is the maximum among these? So 16 is maximum. Okay, I'll just store it. I'll increment my start pointer, because I've used this. Okay, I'll just cut it down, and I'll decrement my I pointer value. Why? Because I have filled this index. Now I want to fill this index. Okay, so I'll try to compare 1 and 3 square. 1 square is basically 1 only, and 3 square is 9. So what is the maximum among these? 9 is maximum. Among this. So I'll just store this. I'll decrement this. This index needs to be filled. Okay. So the end pointer value would reduce. As this index is used. I'll just decrement the value of the end pointer. Okay. Now this 0 square and this 1 square would be compared. 1 square is 1, 0 square is 0. So what would try to fill my value? What would be filling my value? 1 would be filling my value. Okay, my start pointer would increment. My start pointer and end pointer are now pointing the same position. Okay, so this is the only option that I have, so I'll store it here. I'll store it here. Okay, so this is the array what I get. This is the answer that I get. This is the answer that I get. Okay, basically I come onto the two pointer concept just because I was said that I have just observed that the end points can give me the maximum, and while coming onto here, while coming onto the in between the array, these values are gonna reduce. These values are gonna reduce. Okay, so just asynchronously moving them can fill my array, can fill my answer array, can fill my answer array because I want the maximum value. So whatever of these pointers contain the maximum value, I'll just fill it from the end. I'll just fill it from the end. Okay, if this value is maximum, I'll fill it. If this value is maximum, I'll fill it. And whatever value I fill, I'll just increment its pointer or decrement its pointer. Okay, and at a point comes when my start and an end pointer are pointing at the same position. This is my ending point because I don't want the values to be repeated. We don't want the values to be repeated. Okay, so this is my ending point. Okay, understood. Let us try one more test case. -7, -3, 2, 3, 11. -7, -3, 2, 3, 11. Okay. Okay. So if I keep my start pointer here, my end pointer here, okay, because my graph is always like this in a sorted array. These squares are gonna be maximum. As we go towards the end, the value increases. As we go towards the end, value increases. Basically, it is this kind of parabolic kind of graph that these values are forming. Okay, so I just make an answer array that is gonna store my answers, and I'm going to store my answers from the back. This can be the I pointer. Okay, so for now I have to fill this index. For now I have to fill this last index. Okay, so I'll compare the squares of both these values, -7 and 11. What is gonna give me the higher value? 11 square is 121. 11 square is 121, and 7 square is 49. So what is greater, 121 or 49? 121, obviously. Okay, so as we have filled this value, I'll just cross it and I'll move my end pointer here. I'll move my end pointer here. Okay, I'll just delete it. For no confusion should be there, right? So now my endpoint, I will be also decremented. I will be also decremented because this particular value is filled. So I will also be decremented. I will be pointing here. Okay, this I will be pointing here. Okay, now 3 and -7 would be compared. 3 and -7 would become. Just see if there is a value onto the left side, I'll store it. If there is a value greater on the right side, I'll store it. Okay, so it is the asynchronous movement of pointers that is helping us to store the maximum value first. That is helping us to store the maximum value first. Okay, so what is greater, 7 square or 3 square? Basically ignore the sign because it is gonna be squared and the sign is gonna just cancel out. So what is greater, 7 square or 3 square? So obviously 7 square. So I'll store 49 here. I'll score 49 here. I'll increment my counter. I'll delete this. I'll increment my counter. My counter, like start pointer, would be pointing here. My start pointer would be pointing here. Now I'll just see whether my pointer would contain, like it can just these values would be compared. So 9 and 9, these both are equal. Any of the numbers can be stored. So 9 would be stored. Okay. Suppose I am storing this value. So like this, I'll increment my start pointer. Okay. And for the second test case, and for the second value, this end value will be stored because 3 ka square and 2 square, like 9 is greater than 4, so 3 would be stored. 9 is stored here. So now at the point a point comes. Okay, now a point comes when my start and my end pointer are pointing at the same position. Okay, and there is only one option left because my eye is pointing now here. Basically I moved on to here, then here, and then now I am pointing here. Okay, so there is only one option. I just stored the square of it. Okay, so this is what I get after iterating through the whole array. Okay, and this is my ending condition. I wouldn't traverse further. Okay, so if I try to write the code for this, basically what do I want? first let me write the size of the array. I'll denote as a n. My start pointer would be pointing at the 0th position. End pointer will be at n minus 1, basically at the last position. Okay, this is my answer array. That is going to be the same size. That is going to be the same size because my answer array should be the same size as my array, as my previous array. I'll consider all the elements till start less than equal to n. Start less than equal to n. I'll store the values. I'll store both of these values, like the start value and the end pointer value, in the variables a and b respectively. Okay, for you to understand clearly. For you to understand clearly. Okay, and this. Okay, now what I have to see, if a is less than equal to b, a is less than equal to b, basically if my start value is less than equal to b's pointer value, start pointer's value less than equal to b pointer's value, basically what I'll do is I'll store my I value with b. I'll store my I value with b. Yeah, I have to make a end pointer also, that will be starting from n minus 1. Okay, else answer of I would be a. Okay, and this I have to also do that end minus minus and start plus plus. Basically after just storing, after storing, like if I choose the end element, I'll just decrement it. If I choose the start element, I'll just increment it. Also I have to reduce the I value, because if I fill the index, I'll not fill it again, I'll not overlap it. Okay, and at the end I'll just return my answer. I'll just try to run it and see if any error comes. Okay, so the solution is accepted. Submitted successfully. Okay, so if I try to just give you a summary about the solution, what I am doing is I'm just making 2 pointers, one at the start, one at the end, because I just saw that the graph that is forming, that is of like parabola. Okay, parabola. So the values at the ends are greater than the values at the middle. Values at the ends are greater than the values at the middle, because the parabola is like this. Okay, so as I get a greater value, I'll just decrement it, or I'll just decrement it, or I'll just increment it. Okay, I'll increment the start value, or I'll decrement the end value as I get onto a bigger value. As I get a bigger value, and I'll insert that value into my array. Okay, so I'm just traversing from both the ends basically, and I'm storing it into my answer vector. Okay, answer vector. So this is what I am doing. If I just see the time complexity of this solution. Okay, so as I can see, I have an ending condition that my start should be equal to and less than end. Okay, that means if this is an array and my start is here, my end is here. Okay, basically my start will move till a point that it collides with end. Okay, so start and end would be pointing at the same position. So they will stop. So this has traveled till n by 2. So n by 2 plus n by 2 becomes, yes, O of n. So it is O of n time complexity. Okay, what about the space complexity? I'm using an empty array to return the answer. So space complexity will be O of n if I consider the space that is to be returned. Okay, it's the space complexity is O of 1 if I'm not considering the space that is to be returned. Okay, so this was about the solution, squares of a sorted array. I hope you guys like the solution. If you have any doubts, just comment it down below. Okay, and if you like the solution, do like, share and subscribe. Okay, thank you, have a nice day, bye bye.